any question if you have any queries. Now, all of you are very well familiar about this course. This year also, I observed that lot of participants who participate in this course, or you can say who register in this course, more than 3,000 students actually enrolled in this course. And I have also already seen that more than 700 students enrolled for examination. So I am very happy to see this very high response for this course. And what I want to say today that actually this course is really is a very important course, especially those participants who are involved in manufacturing industry, as well as who are interested to do further research work. So this course generally content is divided in such a way. This will give you the overall fundamental knowledge of what it's called welding process, especially those welding process which are widely used in what it's called manufacturing industry. Apart from this thing, this course also will provide you the detailed knowledge, which is little bit advanced types, you can say, and by that knowledge you can do the further research work. What I'm telling, understand? That's why this course is really a very important course, because welding is a joining process. So in this in the course I or means you can say organized in such a way, it generally give you a very well flavored types of taste, you can say, because welding is such a course where you will get the taste of all science related subject, as well as this course also give you the taste of different engineering subject also, like to understand the welding physics, to understand the welding manufacturing process and all the things. Generally a lot of fundamental things is required, like to understand the welding, the science subject like here required what is called physics, mathematics, as well as chemistry related subject knowledge is also required. Apart from these things, in this course, generally in welding course especially, you should have knowledge one what it's called mechanics, solid mechanics, engineering mechanics, fluid mechanics, or you can say thermodynamics related engineering course. Knowledge also required to understand what it's called welding related process. So this course I organized in such a way so you will get both the test, both from the science related topics, as well as you will get the test of different engineering subject also. That's why what happens, I have seen that the response of this course, the responses of this course is really very good, because I have seen this course is rerunning last, you can say, let's say 8 to 9 years. But what happens, nowadays also I am getting such a huge response in this course. I am really very happy to see this response. Now if you have any queries, you can ask me the questions. So yeah, before going to have your queries, first of all, I want to just answer some queries which you have already provided to me in this what it's called previously queried previous sheet, you can say, which you have provided from NPTEL team. So there I have observed that one question I have seen. That question is related to what it's called. Yeah. Hello. But this live is not showing here. Hello. In YouTube, this live session is not showing. हो रहा है ना? No problem. But I am not. हाँ, YouTube में ना तो I am yeah, some question I got actually, yeah, okay. But what happens, this YouTube thinks is not running in my PC. Okay, it is showing only live session, only this screen, initial screen is showing. Okay, no problem. So it's like some student Zafre Khan. Hello, good afternoon, sir. Sit. Okay, okay. Technology. He is from some means manufacturing industry. So good afternoon, Jafre. Some Bablu Kumar also. Good evening, sir. Good evening, bhai. If you have any queries, you can ask me your queries. Pradeep, Mukandam also. Good evening. Hi, bhai. Good evening. Very good evening. So if you have any queries, you can ask me your query because I am now in live session. So first of all, I want to just reply, or you can say answer those queries which is provided in what it's called Excel sheet. This first query is one participant asked that, sir, what is the difference between reverse polarity and straight polarity? If you can kindly clarify this thing very carefully. Yeah, very good queries. Yeah. So I am just going to a little bit show these things in my what is called whiteboard. That will be better for you. So I am just sharing my screen first. So I think it is now visible. So uh, actually here you can see I am going to explain this what it's called straight polarity and reverse polarity related things. After that, side by side, I also will discuss about if you have any further queries that related things also I will discuss. So you see, generally you ask what is the difference between straight polarity and reverse polarity. One minute. Just I am going to explain these things. Then it will be better for you. Yeah. So you can see in case of welding, generally you observe that how the welding circuit is look like. Little bit explaining this thing. Like let us consider this is the power source. With this power source, one terminal is goes to your, you can say, electrode. Another terminal is going to your workpiece material, which you are going to join. Workpiece material, let us consider these two workpiece you need to join. So you see this power source generally connected with domestic power supply. That is generally we use three-phase types of power supply. Now this is called generally electrode, and this is called your workpiece. So in between this electrode and workpiece, here the arc is generated. This is the welding arc. If it is arc welding, this is welding arc. If it is what is oxyacetylene flame types of welding, it is a flame, oxyacetylene flame. Depending upon its type of power source, this can be called as sometimes arc, sometimes it is called as what is called flame. So that depends on your source of heat that you can say. Now, what happens? The one of the terminal of this power source, this connected with electrode, if this is positive terminal, then this types of and if a workpiece is negative terminal, so this if the electrode is positive terminal, then this is called DCEP, electrode positive, direct current electrode positive polarity. What it's called? Direct current electrode electrode. You can say direct current electrode. E represent your electrode, P represent your polarity. So direct current electrode positive polarity. So if it is connected, if this terminal is connected with negative, then this is called DCEN polarity. Later one that I will discuss. Okay. So first of all, I will discuss about this thing. After that, I will discuss that thing. So DCEP means direct current electrode positive. Now you see, if this electrode is positive terminal, then what happens? We know positive generally attract what? Positive things attract the negative things. Opposite polarity generally attract each other. Correct? If it is same types of what is called polarity, then it generally repulse types of phenomena is taken place. So if it is positive terminal, then what happens? Electron have a electron mean negative particles. Electron is a negative particle, so negative particle have a motion. Negative particle have a motion towards electrode. So here in case of DCEP, as the direction of electron is toward what is called is the, as the direction of electron is toward the electrode, that's why this is generally called as DCEP polarity is called as reverse polarity. Reverse polarity, always you should keep it in mind. I have already explained these things in details in my slide. Then also you have a query, that's why I am just discussing here. So here you see electron is moving opposite to the direction of arc, you can say opposite to the direction of arc. That's why it is generally called as reverse polarity. Now what happens? So in case of reverse polarity, what are the things taken place? Generally, because you see negative is the electron, positive terminal is the electrode, then this positive is attracted by negative thing. That is the very common thing, correct? So that's why it is called reverse. So in case of reverse polarity, what happens? These electrons once it move towards electrode, and once it hit on the electrode, there occurs some bombardment types of phenomena. Bombardment of electron is taken place in what is called electrode. Due to these things, generally what happens? More heat is generated in case of reverse polarity. More heat is generated in case of what? Electrode. Like in this case, two third around two-thirds of total heat, or you can say around 70%. Around 70% of total heat is generated in electrode, and in workpiece also there is generated some heat. This heat is generated due to what? As it is negative terminal. That's why what happens in this negative, due to this negative terminal, here generally whatever the ion is there, that ion also attracted, correct? This positive ion is also there. This ion is attracted, and that ion generally hit this parent material. That's why what happens in this case around 30%. In case of reverse polarity case, around 30% heat is generated in what it's called workpiece. That you can say. Total heats, more heat is generated in electrode in case of reverse polarity, and what happens? You can say around one third or around 30% of the heat is generated in workpiece. This you should keep it in mind. This is one case. Another case, generally what is called state polarity. State polarity means if the direction of, you can say, electron is towards the workpiece, that means bombardment of the workpiece is bombardment of the electron is taken place in workpiece, then what should be the polarity of this electrode? So electrode polarity should be negative, and this workpiece polarity should be positive. Then you can say whatever the electron will be here in this arc region, whatever the electron will be here, this electron will be attracted this positive terminal. So you see here then only electron bombardment will be taken place. So in this case around 70% heat is generated in workpiece, and in electrode generally 30% heat is generated. What I am telling, around 30%. That means around one third, you can say. So you see in this case, as the direction of arc, you can say, and you can say the direction of electron is same direction. That's why what happens is these types of polarity have a name. This is called direct current electrode negative polarity, or this is also sometimes called, this direct current electrode negative polarity also sometimes called what is called straight polarity. Straight polarity. What I'm telling, understand? That means flow of electron, if it is towards the arc direction or towards the workpiece direction, then that is generally called a straight polarity. And if the flow of electron is opposite to the direction of workpiece, then that is called generally what is called reverse polarity. This you should keep it in mind. So from here, what happens? You should always keep this thing in mind. Generally, this reverse polarity is preferable where you want to melt the electrode. What I am telling, understand? That means where you want more heat should be generated in electrode. So in which case you want more heat should generate in electrode. So you always keep this thing in mind. Generally, in case of consumable types of electrode, so in case of consumable type of electrode, so whatever the electrode we are using, electrode means whatever the electrode here we are using to generate the arc, that electrode can be consumable types of electrode, or that electrode can be non-consumable types non-consumable types of electrode. So always you should keep it in mind. Consumable types of electrode means this electrode will heat, then it will accumulate heat and it will melt, and it from here generate droplet will generate and it deposit towards to the workpiece weld zone. What I am telling, understand? So in case of consumable electrode, what do you want? In case of consumable electrode, you want, always you should keep it in mind. You want your heat should generate where? Your heat should generate, actually your heat should generate more in what is called electrode, because you want your electrode should melt. So if more heat will generate in your electrode, then what happens? Your more melting of the electrode will be taken place, and then more droplet transfer also you can get. What I'm telling, understand? This you should keep it in mind. That's why for consumable types of electrode, always you should keep it in mind. Reverse polarity is preferable. That means DCEP polarity is more preferable. This you should keep it in mind. That's why you can see consumable types of electrode where it is used. Consumable types of electrode generally use MIG welding process, submerged arc welding process. So these are the different types of welding process where generally you use a consumable electrode. That means this electrode melt, it creates some droplet and it deposited. Correct? That's why what happens in case of consumable types of electrode, DCEP, or you can say reverse polarity is more preferable. Whereas in non-consumable electrode, generally here generally you need that your electrode should not melt. That means in electrode zone your less heat should generate. That's why around 1/3 heat is generated in which case? That is generally generated in case of state polarity case. So non-consumable types of electrode used in which welding process? Like some of the welding process, I am just telling the name, TIG welding, or more popularly it is known as GTAW. That means this is also known as GTAW welding process, gas tungsten arc welding process. It is also used in plasma arc welding process. These are all non-consumable types of electrode. What I am telling, understand? There generally we use what it's called, what types of polarity. Always you should keep it in mind. Non-consumable types of electrode. It is more preferable thing is straight polarity. What I am telling, understand? Straight polarity. Why? Because in non-consumable electrode you need to generate less heat in electrode. This you should keep it in mind. Apart from this thing, another student also tell that, okay sir, why we use aluminum for joining aluminum or magnesium types of material, aluminum or magnesium types of material, why we use TIG welding more preferable, more means more popularly, why we use TIG welding, and why here we use what is called stateful, what why we use here AC types of polarity. What I am telling, understand? AC types of polarity. Why we use this thing? So let's see any other these things I will discuss. First of all, let's see if you have any other queries or not. Okay. Yeah, someone has okay, someone has Pradeep, Mukandam, Indian Institute of Technology, Kharagpur. Amarendra, good afternoon. अमरदीप गुड आफ्टरनून सर फाइनल एग्जाम में कहाँ से क्वेश्चन रहेगा या फाइनल एग्जाम में क्वेश्चन रहेगा whatever the what it's called topics Amarendra whatever the topics we are generally covering in this course from that topics only you can say what I'm telling understand whatever this but you should go through this lecture carefully everything will come from that what it's called lecture note only. Because in this lecture I try my level best to, you can say, provide you all the details things related to fundamentals of welding science and technology. What I'm telling, understand? So everything will come from, that means every question will be based on from this what it's called lecture note only. Okay, so if you go through this lecture note thoroughly, you can get 100 out of 100 marks. What I'm telling, understand? Amardeep, this you should keep it in mind. Now, Amardeep, sir, uh, but okay, you got, I have already told you, Amardeep. So everything will come from lecture note only. Bablu Kumar, sir, please explain numerical problem, question number 10, give in assignment 3. Okay. So what is the question? If you can come in live and explain, then that is better for me to explain, right? Muttu Silva sir, is the final exam is my multiple choice? Yeah, that will be multiple choice question only. There can be one mark question or 2 mark question. What I'm telling, understand? Because 1 mark question will be generally MCQ types of question. 2 marks question can be some numerical question. Numerical question means like some question can be provided, like what happens for a welding process, some welding current and voltage is given, then to do this welding to generate a particular heat, what should be the welding speed. Some fundamental actually welding question can come. Apart from these things, I covered in this course some numerical portion also. Numerical portion, like what happens, some analytical portion also, learn how to find out the optimum power, how to find out the optimum arc length. These types of question means topics also I covered in what is called welding physics topics. So you should go through those topics very carefully. Whatever the means whatever the numerical or analytical problems I am solving during the what is called lecture times, based on those things only everything will come. Okay, so many different analytical things, so many different fundamentals of physics I have physics topics I covered in this course. So whatever the fundamental physics topics I covered during that times, I explained the different fundamental concept based on analytical or numerical types of things. So based on those things, generally what happens, your question will come. I have covered different what is called analytical part. So you go through this lecture note thoroughly, your knowledge will be definitely very good. Very good means excellent, you can say. And what every question will come from these notes only. And I am sure by this course you will be highly benefited. What I'm telling you, will be highly benefited, because this course covered most of the things which is generally used to come in interview, as well as in different interview, as well as in different types of competitive exam also. Jitendra, hello, good afternoon, bhai. If you have any queries, you can ask me. Muttu Selva also, final exam, I have already told you. If you have any queries, you can ask me apart from what it's called question patterns. And Bablu, if you can send me that what it's called, uh, explain the what it's called question number 10 in assignment 3, that will be very good. Okay, what types of question, because that is actually in my another PC computer. So that's why what happened, it is not with me right now. If you can tell me that question, if you can write here, I can definitely explain the thing, right? Otherwise, later on also you can ask me that things. I will see it and I will just convey these things to you. Just I am just sharing my what it's called email ID. So directly you can email me also. My email ID, you can see it's from IIT Guwahati website, that is pankaj.biswas official email ID. Okay, at the rate of IITG sc.in. Okay, here also you can send me your queries if you have any queries later on also. Okay, Jitendra, if you do have any question, any queries, if you have any queries, you can ask me. So you see, now I am going to explain that things, whatever the question on participant ask. So he asked me a question, that means for aluminum or magnesium, these types of refractory types of material, why we use GTAW welding process or TIG welding process. The TIG welding also more popularly known as GTAW, that means gas tungsten arc welding process. Uh, and why also we use here AC polarity? Why not straight polarity alone? So here one thing you should keep it in mind. This aluminum and magnesium, these are all highly your reactive types of material, you can say, because once you just keep this material in open weather, within a fraction of second you can say it is oxidized. So what I am telling under, it is oxidized. So let us consider this is a aluminum plate. If you just keep it in open weather, then what happens, a shine a layer of what is oxide form over the surface which is exposed to atmosphere. Generally that oxide is formed. This oxide has a name that is also called alumina, the Al2O3. This you know. Generally, aluminum have a melting point temperature around 600 degrees centigrade. It has a melting around. I am just because it has different alloy. So generally, pure aluminum have a melting point around 650, 60 degrees centigrade types of temperature. Okay. Whereas whatever the aluminum oxide is generating, this can have a temperature which is much higher, around 2-3 times more than you can say aluminum. So it has very high temperature. It has very high temperature, around more than 1500 degrees centigrade temperature, you can say. So you see, so during welding process, during what is called, why we use first of all aluminum, why we use for aluminum TIG welding, and why we use what it's called AC polarity. AC polarity is what? AC polarity is combination of direct current electrode positive plus direct current electrode negative. This you should keep it in mind. That means AC means it is alternating its polarity. That means sometime it is positive, sometime it is negative. Because AC polarity, what does it mean? That means sometime it's positive and negative. What I am telling, understand? That's why this, due to this power source, once it connected with AC power source, then what happens? This is generally act as a sometime that act sometime as positive terminal, or sometime it is also act sometimes as negative terminal. Now always you should keep it in mind. Generally, this alumina, once it what it's called, once it's deep, once it generally once the welding is done, then this alumina or what if still this tenacious oxide, you can say, this tenacious oxide generally it due to this welding arc and melting of this zone, this oxide generally if this is, you can say, during welding time, as this temperature is much higher than this aluminum or weld material, you can say aluminum plates. That's why what happens, this whatever the temperature required to weld this thing, this temperature is not sufficient, you can say, enough to melt this alumina. What I'm telling, understand? This you can say. That's why as it is not melted, then what happens, this aluminum oxide can embrittled. That means embrittled means it can embedded or it can include with the well material zone. It can include with the well material zone. What I'm telling, understand? So this alumina, once it include, then what happens? It create a inclusion types of defects in weld zone. If it will remain there, then it create a defect, because this is a what if a fully separate types of material than aluminum, whatever the weld material. That's why it's create a separate inclusion in the weld zone. So this is a type of defect. So what happens if in your what it's called TIG welding process, in TIG welding process, if you use, this is positive polarity, if you use positive polarity, during that time generally what happens, we know this electron have a flow towards which direction, towards your, I have already told you, towards electrode, if it is positive terminal. This you should keep it in mind. So positive terminal means you can say DCEP. So that times when this electron start flowing from workpiece to electrode, at that time generally what happens here, whatever the oxide layer is there, aluminum oxide layer is there over the surface of the what is called plate, that aluminum oxide generally break. Due to this, you can say this what is called DCEP polarity, or you can say reverse polarity, DCEP polarity. So due to this reverse polarity, generally what happens, this aluminum oxide is break down. Why? Because due to the flow of the electron from workpiece towards, you can say, electrode direction. So this phenomena have a name. This phenomena have a name that is generally called cathodic cleaning. Cathodic cleaning phenomena. What it's called? This phenomena is known as cathodic cleaning types of phenomena. I have already told you this thing. Then also I am just explaining little bit as you asked this question to me. Now this cathodic cleaning generally occurs with cathodic cleaning occurs in which polarity? If the polarity is DCEP, always you should keep it in mind. That is called, that means reverse polarity case, cathodic cleaning is occur. But in case of cathodic cleaning, here you know the more heat is generated in electrode, which you don't want. Because what we want in TIG welding generally less heat should generate in what is called electrode. That's why what happens, sometimes for cathodic cleaning purpose, we make the electrode positive. But what happens, as this positive electrode hit the electrode more, that's why what happens, it should cool down, not to melt that what is called tungsten electrode. Because if tungsten electrode again highly heated, then it can also melt and it can also drop down to weld zone. That can create also some further defects. What I'm telling, understand? That's why to avoid these things, if sometimes for cathodic cleaning purpose you use this what is called this electrode as positive polarity, and for cooling down this what is electrode, sometimes use these things what is called for negative polarity. Here in this case your less heat will be generated in electrode. What I'm telling, understand? So combining this effect generally reduce the less heat to be generated in electrode. You can say this AC polarity have a heat proportion in workpiece and electrode is around 50-50%. 50% is electrode and 50% is in, so 50% is in workpiece. That way you can say. So that's why for doing aluminum, magnesium type of refractory types of material, what we use during TIG welding, AC polarity is more popularly used. AC polarity, why it is used? Because sometimes for cathodic cleaning purpose, you need more heat to generate in electrode. What I'm telling, understand? And for generally not to consume that electrode, generally you need less heat to generate in electrode. That's why negative polarity you need to use. So that's why AC polarity is required to use for doing aluminum and magnesium types of refractory types of material. This you should keep it in. Apart from this thing, you should keep this thing in mind. Here, what types of inert gas is, because TIG welding means tungsten inert gas. For aluminum and magnesium types of welding, always you should keep it in mind. Here, argon gas is more popularly used because argon gas create more spattering effect, which increase the cathodic cleaning operation. This you should keep it in mind. That's why argon inert gas is used for doing aluminum or magnesium types of what it's called alloy. This you should keep it in mind. Okay. Do you have any other queries? Let's see whether any other queries are there or not. Yeah. Yes. Bablu, sir, please explain numerical things. Okay. Yeah. Bablu, I have already told you that, okay, this question, if you can explain here, definitely I will explain here itself. But what happens right now, that question is not with me. It is in my separate PC. Okay. So later on also I can explain that. If you can explain here what is the question, then also I can explain here in live session itself. Otherwise, later on also you can send me. I have already given you my what it's called email ID. There also you can send me that things. Okay. Do you have any other queries? Jitendra Jadhav, good afternoon, bhai. If you have any other queries, you can ask me. Yeah, Jitendra. Yeah, Jitendra, you ask me. Okay, Bablu send me this assignment question. Assuring linear power source, calculate a open circuit voltage, short circuit current. Yeah, that related thing I am going. Oh, Bablu, so I am going to explain that thing, what it's called in details. How to find out the open circuit voltage or short circuit types of current. That I am going to explain. Very good. I got your question. Arc length voltage characteristics for a welding operation is given by V is equal to 20 plus 40 L. Okay. If the arc length varies between 4 millimeter to 6 millimeter and welding current varies between 450 to what is called 550 ampere, this will be little bit opposite thing. For 4 millimeter your current should be more, and for 6 millimeter your current should be high. Okay, 550. Then what are the things I need to find out? I need to find out arc length voltage. What are the things I need to find? Yeah, I am going to explain this thing very clearly. Okay, I'll just do this thing. Assuming linear power source, calculate open circuit voltage, short circuit. I'll calculate this thing. I'll show you. Then Jitendra Karsu, in case of cathodic cleaning, we use uh, AC power supply, but not use DC. Why? I have already told you. AC power supply means it is a combination of two different polarity. AC means it's sometimes your electrode become positive terminal because above zero crossing it is one types of polarity, below zero crossing it is another types of polarity. This you should keep it in mind, Jitendra. That's why what happens, AC power supply is so AC power supply actually means, it does not means that okay AC power supply means it is a combination of both the polarity. What I'm telling, understand? Because AC polarity, what does it mean? AC sometimes one polarity is in each cycle you get two different polarity. One is positive polarity, another one is negative polarity. Correct? I have already told you. Okay. In cathodic cleaning, we use AC power supply but not use DC. Why AC use? I have already explained. Because DC types of things only we are using. But these DC things, DC power supply, in one case we are using the electrode is positive terminal, and this DC power supply in another case we are using that electrode as negative terminal. What I am telling, understand? So this power source can be DC power source. What I am telling, understand? But that from this DC power source itself, we can use sometimes this is as positive polarity, and this is sometimes we can use that electrode as negative polarity, right? Or separately you can directly use as transformer also. What I am telling, understand? So transformer actually continuously will provide you both the polarity, right? Okay. Yeah, Jitendra, thank you. So I am going to explain the queries of Bablu Kumar. Then it will be very good for Bablu also. Yeah, I am going to explain Bablu. So what you ask, I am noting it down. First, you have asked me a question that, yeah, very good. 1 minute. that thing I am going to explain. So first of all, I am sharing my this thing. Okay, I'll use whiteboard. That will be better for you. I think it's this. Here I'll use these things. So here I am going to explain. So you have given power source characteristic as. So I am going to explain those things, whatever the things are there. So you have told 20 plus 4L is the voltage. Voltage is a function of arc length, which is a function that is your 40 plus 4L, 20 plus 4L. And if the arc length is 4 millimeter, at the time of 4 millimeter, your current is 550. And at the time of 6 millimeter, your current is 450 ampere. Okay. This is ampere. Okay. Now, what are the things you need to find out? What is your short circuit current and short circuit voltage? This you need to find out. So I am just doing these things. Then it will be very clear to you. So here already it's mentioned that you can see your power source characteristics is considered as a straight line. Correct? So here I am drawing this thing. Then it will be better for you. Let us consider. Generally, you know, this horizontal line is your current and this vertical axis represent your voltage. This you know. So here the arc source characteristics is considered as a straight line. So you know this maximum voltage is known as open circuit voltage, or you can say here I am writing VO, and this maximum current when the voltage is 0, at that time whatever the current is there, that is generally called short circuit current. During shorting of the arc, whatever the current you got, that is called short circuit current. So you know here for what, for if here one thing you can observe that your V is a function of what, 20 plus 4L. Okay. Now what are the things given? If what if your arc length first case 4 mm, then current is, so if during 4 mm, so what is your working point? First of all, for 4 millimeter L, that means for L is equal to 4 millimeter, you can say L is equal to 4 millimeter. What is the voltage you are getting? So V you are getting as 20 plus 4 into 4. That means you can say 36. So at that time, generally, what is your current and voltage? Your current is given as, what are the things? 550. So your current is at that time generally 4 ml. Your current I is equal to is given as 550. Clear? This thing is already given. Now for L is equal to 6 millimeter, what are the things you got? Your L is equal to 6 millimeter, you got V is equal to what? V is equal to 20 plus 4 into 6. That means you can say 24, 44. At a voltage of 44, you are getting current is equal to I is equal to, you are getting as 450. This 2 point is given. So let us consider, you see, so here you can see for, so what are the things are there? For 36 voltage, here you are getting current as given as what? Your current is given as 550. Please, clear? So from here you can get a very interesting types of relationship, you can say. Like let us consider this is your A, this is your B, C, D and E. These are the, what is called, these are the two triangle I am considering. Which triangle and which triangle I am considering, that you just see it. Okay, so two triangle I am considering. One triangle is A, B, C, Another triangle I am considering as triangle ADE. That means on big triangle and on a small triangle. From this big triangle and small, from this similar, these two triangles are similar to each other. That you can see ABC and ADE, these two triangle. From this two triangle, what you can say? This divided by this, correct? And this base divided by, you can say, this base. So that I am just doing. So here what I am doing? AB by what? AD, from the similarity of these two triangles. AB by AD is equal to, you can say, BC by DE. Correct? BC by DE. What are the things here you are getting? So AB is for how much it is given? AB is given as, AB you can write as V0 for this case, you can write as our open circuit voltage minus 36. This is your AB divided by AD is how much? AD is actually V0. Okay. This is actually equal to BC is how much? BC is given as 550 and DE is given as IS. So this is the equation of in terms of V0 and IS. This is equation number 1. So here two variables are there. One is your what is called, one is your IS, another one is your what? Always you should keep it in mind. Another one is your IS, another one is your what it's called V0. So two variable unit you are here, it is there V0 and IS. So for that actually this is one equation you got. Another equation also you need to find out. Always you should keep it in mind. For higher the voltage here itself, you see, for higher the voltage, you see, generally your current is lowered. So whatever the things here is given, this is you should keep it in mind. In this question, it is mentioned that for 4 millimeter, your current is generally considered as what is called 450, but that should be little bit opposite. That should be for 4 millimeter arc length, your current should be high. What I'm telling, because your voltage is coming less. For lesser voltage, higher current. Higher voltage, lesser current. This you should keep it in mind. Okay. So just you interchange these two, then you will get the thing. So for in second case, this is actually become what? This is become, so second case, let us consider 44. This is your 44 and this corresponding to your less current, that is your 450. Correct? This corresponding to your 450 already is given. So here from this two triangle, let us consider this is A. Already E I have taken. Let us consider I am taking here MN, another 2 point, MN point. So here which two triangle in this case I need to take? Triangle AMN, and what are the other things you need to consider? Another triangle you need to consider, that is ADE is there already. So from this you can get another equation, that is you will V0 minus 44 divided by V0 is equal to your 450 divided by IS. What I am telling, understand? So this is another equation, equation number 2. So by solving this equation number 1 and 2, whatever the V0 and IS you will get, that is your V0 is your open circuit voltage and IS is your short circuit current. Okay. Is there any Bablu? I think it is now clear to you. Bablu, is it clear to you? I think Bablu, now it is clear to you. You can solve these things. I have already given. But one thing you should keep from this power source diagram itself, you can observe that higher the voltage, lesser the current, lesser the voltage, higher the current. Always this thing you should keep it in mind. So by using 4 millimeter arc length, you will get less voltage than 6 millimeter voltage, correct? So that's why for 4 millimeter arc length case, you should consider your current is 550, and for 6 millimeter arc length case, you should consider your current as what is called 450. This one you should keep it in mind. Okay, bhai? Okay, just I am stop sharing these things. Okay. Yeah. Any other queries if you have, you can ask me. I am very happy to see your queries because this is really very important queries you got. Okay. Actually, I will tell my TA to correct that things. Okay. For 4 mm to 6 mm, welding current varies. That should be 550 to 450. Just other way they, but respectively word also he need to mention. Okay. That I will tell him. But what happens as the respectively he has not mentioned. So you can consider this thing. For higher voltage, lower current should be there. For lower voltage, higher current should be there. That means for higher arc length, you should use lower current. For lower arc length, you should use higher current. This you should keep it in mind. By this, you can solve the problem. So any other queries? If you have any other queries, you can ask me. Now, apart from these things, another one question also ask. You see, what is UCS? So I have already told you that UCS means unit of crack susceptibility. So I have already discussed these things in details in case of submerged arc welding. So in case of submerged arc welding process, I have discussed these things UCS in details. So UCS actually is a function of different types of material composition, well material composition. What I am telling, understand? Whatever the well material composition is there, based on this well material composition, this UCS is find out. What I am telling, understand? So UCS means unit of cracking susceptibility. S represents susceptibility. Generally, one thing you should keep it in mind. This UCS generally based on material composition. You should always keep this thing in mind that material composition have a significant effect on cracking right types of phenomena in weld zone. What I'm telling, understand? These cracking types of phenomena generally, in welding process, there can be two different types of cracking. One is called cold cracking, another one is called hot cracking. I have already discussed this thing in detail in my course. So you go through my lecture thoroughly, you will get the detailed information. So what happens in case of like what happens, this cracking phenomena, or you can say generally depends on, you can say mainly uh, 2 3 types of factors. So one of the factor is material composition, another factor is what is called grain orientation. Okay, another factor also is generally depends on hydrogen embrittlement. Different types of phenomena are there. So one of the composition for cracking in weld zone is affected by one of the phenomena is like material composition. So that's why what happens for doing welding. So that material composition of that weld material should be chosen carefully. What I'm telling, understand? Otherwise, what happens? There is a chance of cracking in the weld zone. So that's why this unit of crack susceptibility is one of the factor which is calculated based on material composition. So if this unit of cracking susceptibility value is more than some limit, what I'm telling, understand? Then what happens? There is a high chance of what is called cracking. And if this value is less than some limit, then there is a less chance of cracking. Lower the value of unit of cracking susceptibility, better is the weld quality, you can say. That means less chance of cracking of that weld zone. This you should keep it in mind. Okay, now here you can observe that here generally this UCS is, you can say, increase. UCS is increased by some material composition like carbon, phosphorus, sulfur. What I'm telling, under these are the different types of materials composition or material elements are there, which generally affect the UCS drastically, because higher the value of carbon percentage, phosphorus percentage or sulfur percentage, higher is the chance of what is called unit of cracking. Higher is the chance of cracking in weld zone. What I'm telling, understand? But some other element also are there like manganese, then silicon. So these types of material have generally what is called, you can say, which reduce the unit of crack susceptibility, you can say magnitude or value. What I'm telling, understand? That means it has negative effect. So you see, that's why. So proportion of this material have a significant effect on what it's called cracking of weld zone. So you should always keep this thing in mind. For during choosing of the material, you should carefully choose the material composition. Apart from the, not only this unit of crack susceptibility affect the weld cracking phenomena, apart from these things I have already told you, it's also affected by hydrogen embrittlement, cooling rate, what I am telling, understand. Then some other case also, it is a other grain orientation, how the grain orientation are there. So these 3-4 factor combinedly generally affect the cracking phenomena. This you should, I have already discussed this point in details during the lecture of submerged arc welding. So you go through this submerged arc welding thoroughly, you will get the detailed information from there. So if you have further queries on this, you can directly ask me. Then also I can discuss this thing in details in next session. Or not only will wait for next session. If you have any further queries, you can directly mail me in my official mail ID, which I have already today provided you. So you can directly mail me your queries for further clarification. What I am telling, understand? Yeah. Any other queries? If you have, you can ask me. Shoham, sir, for the final exam, would question come from assignment? Yeah, definitely. Some question will be similar to that assignment question. What I am telling, understand? You can say. Bablu, thank you. Thank you. Why? If you have any other queries, you can ask me anytime. You are always welcome to me. Okay. I think no further queries are there. So time is also off, you can say. So as no further queries are there, so hello, shall we close the session? Hello, am I audible? Yeah, Rekha, so shall we close the session? Because time is also up, no further queries are there. Okay, so you are closing, correct? Okay, thank you so much. So I am leaving. Shall I leave? Okay.